All right, well anyways, we're on to the last tutorial in this unit. This is not a very big one, as you'll notice, if you're judging by how many pages are there. 2 pages. In the Math 12 curriculum, there's not even actually that much about base E and natural logarithms, but it only seems natural to talk about natural logarithms when you're learning about logarithms, because if you look at your calculator, it's the only other logarithm button you have on your calculator. You have the logarithm button, and the logarithm button's the inverse of the anti-logarithm button, right? 10 to the x and log x are inverses of each other. In other words, as we've said, it's a very precise mathematical way to say it. These buttons undo each other. There's only one other base that your calculator has. It's hard to probably know at the beginning here why this base is on there, but there's base E and the inverse of that, natural logarithm. I don't know why they abbreviate natural logarithm as ln, unless it's somehow French or something like that, log naturel. I don't know. But that's what this is. ln is natural logarithm. I think I've put it in there somewhere, natural logarithms. But people are lazy, so even when they see ln, they don't say natural log. You can, but sometimes people just say ln x. Not written out ln x like that. That's just for pronunciation. It's a number just like pi. It's an irrational number. If you go to your calculator, you can see what it is, because you have a button right below here. You have the natural log button, and you have e to the x. You actually have an e over here if you just want the number e without the to the power of something. So if you do that, e is this number right here. This number comes from, without getting into it too much, sometimes in the past we've gone through in Math 12 seeing exactly where that number comes from. I don't know if it does a lot for what we do in Math 12 because we really don't use it that much. The outcome in Math 12 says, basically, you know how if we look up here, the objective, the Math 12 objective isn't, you have to be completely familiar with base E and natural logs, and you have to know everything about it and where it came from. Basically, it kind of boils down to the Math 12 student should not freak out when they see the letter E. Okay, that's essentially what it says. Is if it comes up in a formula like this, Math 12 students for some reason have a tendency to freak out and say, "Oh, it's that E stuff. I don't know what that E stuff is. That stupid E thing. I didn't even try it." That question. I don't quite understand that, because you don't do that for pi, right? Maybe when you first learned what pi was, you might have said, "Oh, pi, I don't know, that number, whatever it is, I didn't even try that question." But you realize now it's just a number. It's not a very easy number to work with, but it's a number, and E is the same thing. So if you have a formula with an E in it, as long as you realize it's just a number that you can use like any others, right? Like this. This is the kind of question that for some reason more grade 12s than should freak out because there's an E in the thing. It's just a number, okay? So going back up here, I did want to give you a hint as to where E comes from, and you could experiment with it yourself. If you think about compound interest, if you take an amount of money, like $1, and you invest it at 100% interest, and you invest it for 1 year, just to keep things simple, I'm using 1 all the way across, but it could be any number. If you compound something more and more often, I'm not sure how familiar with compound interest you are, but if you compound something more and more often, what happens to the final amount of money that you have? And I don't want this to kind of make you freak out more about E, but I do want you to have a slight sense of how you can see where it comes from. If you start with $1 and you invested for 1 year at 100% interest, and it's not compounded more than once a year, how much do you end up with at the end of the year? $2, right? 100% interest is simple. You get $2, right? You start with $1. At the end of the year, you get 100% interest, so you get another dollar, you get $2. If this is once per year, okay? So the variable I'm making it is number of compoundings in the year. And this is the amount you have at the end. If you compounded it twice per year, how much would you have? Harder to figure out, but let's think about this. Start of the year, you have $1. The whole year goes by, then they pay you the interest and you get your dollar, you get $2. That's if it's once per year. If it's compounded twice per year, halfway through the year, they calculate your interest. If you're getting 100% per year, how much do you get per half year? 50%, right? So halfway through the year, they give you not a whole dollar, they give you 50 cents. So you're up to $1.50. And then another half the year goes by, and now you get the other 50%, but you get 50% of this new number. So how much do you get at the end of the second half year? You get 75 cents, so how much are you actually going to have at the end of the year? $2.25. Now, I don't want to go too much more than that, but what do you think happens as you increase the number of times you compound it? Like if it was 4 times per year, which is called quarterly, or monthly, or more and more, right? I don't want to get hung up on the numbers and how you calculate it, because I think that leads to why grade 12s freak out when they see E, is because we go through a very long calculation and background into where it comes from. All I want you to understand is the more often you compound it, what happens to the amount of money that you have at the end? Just intuitively, why did you get more money here when you compounded it twice? What happened in the second half of the year? The first half of the year you got interest off the original amount, but in the second half of the year you got interest off the original amount and some interest, right? Compound interest is getting interest off of interest. So in the second half of the year you got interest on the original $1 and on the 50 cents you got in the first half. So the more often you compound it, this is going to go up here. Actually, in our situation, this function here, where n is the number of times you compound it, that's going to say how much money you have. If you know a compound interest formula and you fill in some values, you can see where that comes from. But just to, I said I wasn't going to do this background, and now it seems like I am. This is the really brief background, though. You can trust me that this is the compound interest formula filled out for where x is the number of times you compound it. And we're just going to look at a table here. I'm actually going to make it where I can put my own numbers in. Once per year you have $2 at the end. Twice per year you have $2.25. 4 times per year you have $2.44. We could go to monthly. We could go to weekly. What would weekly would be 52. What would it be if you had 26 times per year? Every 2 weeks? Every 2 weeks is called biweekly, right? If you have biweekly there. One we could have put in here was 24. Every half month. That's not called biweekly. What's every half month? It's called semi-monthly. If it's every half of something, it's called semi-monthly. If it's every 2 of something, it's called bi, whatever that is, right? Bi-weekly is 26 times per year, every 2 weeks. Semi-monthly is 24 times. Anyways, the more you do this, if you did it daily, or you did it every hour, what's happening with those numbers? I know they're pretty small there, but there's a huge change from once per year to twice per year, a little bit less of a change, less of a change. Going from every day to every hour, hardly a difference at all, right? And the farther you go with this, the less difference it makes. There's a limit to what happens here. There's a limit to how much the effect of compounding changes the more you compound. And the limit is actually this E, this number E. That's where it comes from. Right? The more times you compound, the less difference it makes. The limit of this, as you keep going, is E. This is where this number comes from. You don't have to know that for Math 12, but I think it helps to see where this comes from. Wait, I'm at 10. Thank you. Okay, so before we use something, you should just know that